Howdy. A very strong 7.7 earthquake struck basically near Tonga, in the region of Tonga, in the greater region of Tonga. 7.7 2 hours ago, it had a depth of 37 kilometers, which is not that deep for such a strong quake. And there has been many other rather strong quakes in the region since. And just for context, Tonga is somewhere here, I think, here. Not too far. And of course, they're all connected. There's actually a quake here 9 hours ago. Pangai, Tonga, 172 kilometers in depth. Going over to the National Data Buoy Center, which somehow became very, very hard to use at the phone. But anyway, let's try. There are several buoys in alert mode. And I say it again, I'm not an expert in these, but you can see there's something going on here. Some ground movement, which then moved the water, of course. And there's also one here on the other side of Australia. This doesn't look too wild, but I don't know. I'm not an expert in these. There are plenty of people who know much more about these, so check them out, for example. And as we are talking about earthquakes and possible tsunamis, we might have to talk about volcanoes as well. And in particularly Popocatepetl volcano, Mexico. Violent eruptions continue to illuminate most of edifice with glowing lava bombs. I couldn't make a video yesterday anymore, but I just want to point one single thing out for those who know where and what to look for. I would say, in my opinion, these look like plasma phenomena. Now we have the first time a picture with color, because the live streams are usually black and white. I have to try to find this from a live stream, and then we could make some analysis and stuff like that. And the first thing is, like, if it's also visible in the live stream, we can probably say, yes, that's not just some odd picture occurrence here on this picture, because it really happened. I made some enhancements to this in order to make it visible a little bit better. The screenshot, the picture quality of the picture isn't too good. Here I marked it once again. And it's a little bit more enhanced. Yeah, like I said, the picture quality isn't the best. But I don't really think that these things here, this glow, is created by lava bombs. And here it's still more enhanced. And also, like, if you would trace this back, it would go beside the volcano. The angle should be different, basically. If it would originate from the actual crater. But as we have seen many times, they don't. They appear somewhere in the sky, and then from then they shoot up. That's the reason why they are not originating or not aimed at the crater itself. Furthermore, one thing I have been thinking about in recent times very much is a certain metal and sulfur. And just before, I stumbled across some news which talks about water. Yes, I have been talking very much about water also. So let's have a look at what I just had in my feed which is in a way a breakfast for the mind. Phys.org, 14 hours ago. Chemistry, material science, non-toxic powder uses sunlight to quickly disinfect contaminated drinking water. Yeah, I think it has to be non-toxic. You know. But anyway. And the thing is, I have been making videos about like my microwave stones, how they reacted to electromagnetic energy. I have been talking about this, was it hydrogen? And I don't remember. The other thing, this this gun where the doctor person is pointing a laser pointer into this kind of device, and when he uses green, I think it just, you know, how much energy and how specifically certain wavelengths of light can have huge reactions in things, such as photosynthesis. At least 2 billion people worldwide routinely drink water contaminated with disease-causing microbes. Now Stanford University scientists have invented a low-cost, recyclable powder that kills thousands of waterborne bacteria per second when exposed to ordinary sunlight. The discovery of this ultra-fast disinfectant could be a significant advance for nearly 30% of the world's population with no access to safe drinking water. According to the Stanford team, their results are published in Nature Water on May 18th. I didn't know that there's this kind of Nature Water. Interesting. Waterborne diseases are responsible for 2 million deaths annually, the majority in children under the age of 5. Said study co-lead author Tong Wu, a former postdoctoral scholar of material science and engineering in the Stanford School of Engineering. We believe that our novel technology will facilitate revolutionary changes in water disinfection and inspire more innovations in this exciting interdisciplinary field. Conventional water treatment technologies include chemicals which can produce toxic byproducts and ultraviolet light. Do you notice it? The chemical reactions produce ultraviolet light, which takes a relatively long time to disinfect and requires a source of electricity. The new disinfectant developed in Stanford is a harmless metallic powder that works by absorbing both UV and high-energy visible light from the sun. The powder consists of nano-sized flakes of aluminum oxide, molybdenum sulfide, copper, and iron oxide. We only used a tiny amount of these materials, said senior author Yi Chui, the Fortinet Founders Professor of MSE and of Energy Science and Engineering in the Stanford Durr School of Sustainability. The materials are low-cost and fairly abundant. The key innovation is that, when immersed in water, they all function together. So they create an electromagnetic field, I think. Fast, non-toxic, and recyclable. After absorbing photons from the sun, the molybdenum sulfide copper catalyst performs like a semiconductor metal junction, enabling the photons to dislodge electrons. Yeah, I haven't read it yet. The freed electrons then react with surrounding water, generating hydrogen peroxide and hydroxyl radicals, one of the most biologically destructive forms of oxygens. The newly formed chemicals quickly kill the bacteria by seriously damaging their cell membranes. For the study, the Stanford team used a 200 milliliter, 6.8 ounce beaker of room temperature water contaminated with about 1 million E. coli bacteria per milliliter. We steered the power into the contaminated water, said co-lead author Bo-Fei Liu and former MSE postdoc. Then we carried out the disinfection test on Stanford campus in real sunlight and within 60 seconds, no live bacteria were detected. The powdery nanoflakes can move around quickly, make physical contact with a lot of bacteria and kill them fast, he added. The chemical byproducts generated by sunlight also dissipate quickly. The lifetime of hydrogen peroxide and hydroxy radicals is very short, Kui said. If they don't immediately find bacteria to oxidize, the chemicals break down into water and oxygens and are discarded within seconds, so you can drink the water right away. The non-toxic power is also recyclable. Iron oxide enables the nanoflakes to be removed from water with an ordinary magnet. In the study, the researchers used magnetism to collect the same power 30 times to treat 30 different samples of contaminated water. For hikers and backpackers, I could envision carrying a tiny amount of powder and a small magnet, Kui said. During the day, you put the powder in the water, shake it up a little and put under sunlight, and within a minute, you have drinkable water. You use the magnet to take out the particles for later use. The powder might also be useful in wastewater treatment plants that currently use UV lamps to disinfect water, he added. During the day, the plant can use visible sunlight, which would work much faster than UV and would probably save energy. Yeah, probably, Kui said. The nanoflakes are fairly easy to make and can be rapidly scaled up by the ton. The study focused on E. coli, which can cause severe gastrointestinal illness and can even be life-threatening. The U.S. Environmental Protection Agency has set the maximum contaminant level goal for E. coli in drinking water at 0. The Stanford team plans to test the new powder on other waterborne pathogens, including viruses, protozoa, and parasites that also cause serious diseases and death. Here's the link to the actual paper, DOI. Now let's try if it's for free. If it's for free, it would be very cool. If it's open access, access via your institution. Access through institution. Rent or buy this article, $40. So we probably have to wait until we can read that. Or at least I do. Or if you want to pay, you can pay it and you can read it right away, but I won't pay for this. So, there's like drinking water pouring out of the ground all over the place. So, and I still think the sun is the main driver behind this whole process. It's a circuit. It's the electrical circuit of Earth, why the water is coming up from the ground. I have been talking about this many times. Mountain waters. Yeah. The sun is mentioned in the mountain water paper. But anyway, I think I leave it here. Thanks. Bye.